In this problem, we're being introduced to the basics of equivalent capacitance. We know that capacitors in series like this are going to add together by doing a 1 over the capacitance plus 1 over the next capacitance and then raised to the negative first power. This is very similar to resistors. However, this would be more similar to resistors in parallel. You can think of capacitance as the opposite of resistors in parallel or inductance in parallel. So normally if a resistor is in series, remember this is resistors. If a resistor is in series, we just add them together. However, if capacitors like this are in series, we are going to have to do the equivalent of a resistance in parallel formula. So if we were to plug these all into a calculator, we would need our first parenthesis, 1 divided by our first capacitor, plus 1 divided by 7.9, plus 1 divided by 2.1. These are all of our capacitors, and this is just being raised to the negative first power. If we do this, we are going to get 0.76. And this is in microfarads, and this is the answer to our problem. This is how you would go about solving capacitors in series. And remember, if they are in parallel, you would just add them together like resistors in series. Since this stuff can be a little bit confusing, if you have any questions about the material, you can leave them in the comments. If you want more intro to circuit analysis, there's a playlist as well as a public Google Docs with notes covering this entire course.